I think we're going to get started, and then if anyone wants to join a bit late, then that's fine. I'm not going to talk very long because Allan is the star of the show, but I just want to say thank you everyone for coming. It's been really exciting organising this because so many people love this machine, which it's really lovely to know that people are as obsessed with it as me. I also want to thank Nicholas Barr for coming from the LSE. He actually he knew Bill Phillips, so if you have any questions about Bill Phillips, I'm sure he would be happy to talk about him. And most of all, I want to thank Allan. So Professor Allan McRobie is from the engineering department, and he restored the machine back in 2002, is that correct? And has been running demonstrations ever since. The machine sat still, obviously, for a couple of years now because of COVID. So when I asked him to do this, I don't think he realised how much work it was going to be for him. We've been in and out of this room quite a lot over the last couple of weeks. When we first turned it on, water just sort of poured out of the top. So we fixed it, I think, in the spirit of Bill Phillips with WD-40 and electrical tape mostly. And now it doesn't seem to be leaking that much. So yeah, I think that's everything I was going to say. Oh, one final thing. We've been talking a little bit about the future of this machine and maybe thinking about getting students together who are interested in it to learn how to use it and how to maintain it. So if you are interested in that, then I think you'll have my email address, so please do get in touch with me. Yeah, that's everything. I'll hand over to you.
Thank you, Emily. No, it's thank you all for coming. It's a great pleasure. It's an honour to give this talk, actually. I've said before I would give this talk to an empty room. This machine is so good. This is the star of the show, not me. The machine is the star of the show, and Bill Phillips. And it's a great pleasure with Nicholas here as well. It's fantastic to do this. We have tried to fix it, but I don't know it quite works 100% at the moment. So we're going to do some experiments, but they might not work. Okay, so
it's a bit sticky.
No, it does work. I've got graphs to show that we can get it to work, but the last few weeks where we've just, after post-COVID, it's still got a bit of gunk on its lungs, I think, or something. So this is the machine. It's a fantastic machine invented by Bill Phillips in about 1950, and it's a model of the national accounts. Now, be aware, I'm an engineer, you're all economists, all right? I will get most of the things I say wrong, but that's fine. So will you, because you're economists. And I know how this works. When I say something wrong, economists say, no, that's not right. And then someone else says, no, that's not right either. And then the economists start fighting with each other. So I just stand back. So that might work like this. So it's a model of the national account. So I give this talk to sort of A-level kids, and let's do the geography first. And it all starts at the bottom with this big tank of water at the bottom, which is the total quantity of money in the economy. It's just a big tank. There's a diagram of it over there. It's a tank, and it comes out the side of there into this sort of little holding tank, because round the back there's a pump, which we think is a pump off a Lancaster bomber, because in the 1950s, around 1949, it was very common to use ex-MOD equipment in your laboratories because there was lots of it around. So there's a sort of Lancaster bomber pump, and Nicholas is nodding his head. It then comes up here, so this is national income coming in at the top. So national income comes down here. Taxation, one of the two certainties in life, comes off this way to the government sector. So the government is over here. This is income after taxation, Y minus T, income after taxation. Apparently some people save, so that goes off to the savings. The bank is over there, so that's the sort of savings go off to the bank. And this is your income after taxation that you haven't saved, is your consumption coming down here. So already we can see that he's kind of got the geography of London right. So you've got the government over here in Westminster, you've got Oxford Street consumption here, and you've got the banking over in the city there, so you can remember it that way. The bank doesn't just keep it stuffed in a mattress, people borrow it to invest, and so that comes down here. The government, likewise, they spend the money, and these three flows come back together to give you the total domestic expenditure coming down here. Some of that goes off, money is spent on imports, so again, think of this is the Channel Tunnel or Felixstowe over this way, Belgium and so forth are over that way. So the money for imports goes that way, and certainly in the 1950s we had exports, so that the money comes in that way from exports coming there, and then they all go back into the tank and it all goes round again. So I've sort of drawn that, Emily's drawn this on the board here. The M1 goes round, just to remind you, you know all this. When students do it, when I do it with A-level students, I give them a piece of chalk and ask them to show what they've been taught, and they usually draw households and firms, and then they have lots of arrows, but they still end up with all the same sets of lines of inputs, the tax going out, the government expenditure going in, they still end up with the same ones. But you've got to fold your households and firms over on top of each other to get one model of total aggregate demand. But it is basically A-level economics with your, as I say, government Oxford Street Bank over that way. There is another feature on the machine which is over here. It's this thing there, which is this dotted line here, which is that the government can run a budget deficit. It can spend more than the income tax goes in. And so there's this pipe at the back, which economists think is funny, that you can't see what the government is doing, but the government is really borrowing money out the bank to run a budget deficit, which then comes down that way. And then the other thing is this pipe here, which is where we can print money. So I call this the Royal Mint, but it's probably more correctly the Treasury, I think, can print money and feed that into the bank there. We could do quantitative easing or whatever and feed that in there. And this is this pipe here, which comes in there, and there's various attachments that I can use to do that. And I'll switch it on in a minute, but it makes a bit of a noise, and then I'll have to talk a little bit louder. So before we do that, we're going to do 3 experiments today. We're going to do a Keynesian multiplier experiment with a balanced budget at fixed interest rates, and then we're going to do it with a fixed quantity of money, and interest rates can vary, and then we're going to do it with a thing called the accelerator, which I don't think has much provenance in economic theory these days, but we'll show you how the accelerator works on this machine, which is a model of human optimism, or it's a hole in a bucket, which is a very insulting to humans, I think, but it's also a model of capital deficit. So I should say a few things about Phillips. Phillips was an amazing chap, and this is where Nicholas could correct me if I get it. He was a New Zealander. He grew up on a farm in New Zealand, a dairy farm. He was a very sort of hands-on person. Get him in the morning, you fix the electric fence. I think when he was a kid, he had some pulley you could pull, which would turn his bedroom light off. He pulled a pulley which went over lots of pulleys, this wire, and it detected a sluice gate so that the water didn't go to the water wheel that was generating the electricity. So it's all very, come in, have a seat. And then he then set off into the world, first as a qualified electrical engineer, became a qualified electrical engineer. He went over to Australia. He was a crocodile hunter. He worked as an electrician in a gold mine. He had all sorts of jobs in Australia, and then gradually made his way across via the Trans-Siberian, I think, to the UK when the Second World War broke out. And he then had to go back. He joined the Air Force and became a war hero. And I'll tell you more about that, but very colourful character. Shall we just turn this on first? I think we should. So I think Emily can stand at the front and watch and catch. if anything goes wrong, Emily can catch it on. So I'll just turn it all on first to get it going. And here we go. Turn on the mains. It's all right. Okay. We can do that. Sort it. 1, 2, 1. We'll go for. So that's good. So the water's going around. There's these danger 240 volt signs on it. That is no longer 240 volts. The one thing we did do before 20 years ago was to step this down to 20 volts so that it is now. It used to be sort of these water level detectors. I think with 240 volts straight into water. I'm just boof, boof. And I asked Nicholas about this. Did you really do this? And Nicholas said, I don't think anyone ever pointed that out to me before. Which is, oh gosh, I'm glad you're still here to tell the tale, Nicholas. But we've stepped this down and it's no longer 240 volts. But it's a bit more temperamental because we've only got 20 volts to play with. So we do it. So the experiment we're going to do is is going to be on a Keynesian multiplier. But first what I'm going to do is I'm going to shut down the foreign sector. So this is all the foreign sector. We're just going to shut this down and we're going to concentrate on the government, the high street and the bank. And in fact, we're going to concentrate on the bank and consumption in the high street. We're just going to concentrate on these two for the first experiments. And so to explain how this all works, let's just start at the bottom. So I said at the bottom there was this big tank which is called M1. At the bottom, the total quantity of money in the economy is in that tank. And what Phillips has done is a slot in the side of that tank, which is just over here, there's a funny shaped slot, and the equation for this slot is a sort of funny 1 upon the square root of the height, because the flow over a weir goes as a 3 upon 2 power law, which is highly nonlinear, and Phillips doesn't want a nonlinear equation. He wants a linear relationship between the flow and the head behind it and the flow. So he's come up with a funny shaped slot, which then gives him a linear relationship. So there's now a linear relationship between the flow and the head, which is also a linear relationship between the flow, which is national income, and the head, which is proportional to the volume, which is M1, the total quantity of money. So that, I believe, is the Cambridge equation. So Cambridge in our geography is down at the bottom of the tank. That's the Cambridge equation. Is it or is it not the Cambridge equation? Emily, would you call that the Cambridge equation? But anyway, this is the basic quantity theory of money. It starts off with this linearity. It's called the Sutro weir at the side there. So now let's have a look at the bank. It's very clear here what's a stock and what's a flow. And there are very few stocks. There's a stock at the bottom, and there's this stock, the stock of loanable funds in the bank. And the bank has got this big float on it. And what you'll see all over the machine are these little tiny perspex graphs. And I'll just move them. You find the perspex graphs? Give me that one, yeah, that one, put it back that way around. So there's these little perspex graphs with slots in. I don't know if you can see it at all. There's a sort of slot in it, and the slot has got a pin that sticks through that, and this pin is then attached to a slider, which we can show on that one. So if you put that one back the right way around. These sliders, so these sliders sort of open and close, and they constrict and destrict these waterfalls. So these sliders sort of do this and open and can close the amount of water flowing in and flowing out here. So think of this stock, now just think of it as a stock of something, so that as the float rises, these are basically your supply and demand curves, these two graphs with the slotted pins in. So as the stock depletes and it goes down, the float comes down, and so the price goes up because the stock is rare. So this comes down, and so that essentially that pin moves up there and the price goes up. And as the price goes up, it opens the supply and it closes down the demand, because the price is high, so it closes the demand. So that's how it does the basic supply and demand curves with this float on here. So this is actually a stock of money, a stock of loanable funds. So the price on this axis is the price of money, and I asked this A-level kids, what's the price of money? And they're, oh, don't know. But it's obviously it's interest rates, the price of money. So this is a model of the bank and interest rates. So when it's an inverse relationship. So when the stock is low, the price is high. So interest rates are high. So we'll need to know this when we do the experiments. When the bank is low, interest rates are high. And when the bank is high, interest rates are low. So there's this reciprocal relationship here. And it's not perfectly reciprocal hydraulically, so he's put this sort of curve on at the end to get this inverse relationship. And I believe this curve is your liquidity preference function, if I remember. And we can adjust that. But that's the basic concept there. And so it's the supply and demand of loanable funds. So this is sort of investments coming in, and this is savings coming in at the top and investments going out at the bottom of the bank there, like so. So what we're going to do, we've settled it down. We're going to run a balanced budget. We're going to have 1 billion a year, 1 trillion a year, whatever it was in the 1950s. Let's say a billion a year at the top and a billion a year out at the bottom. The government's going to run a balanced budget, and we're not going to have any taxation rate. There's just a constant income tax, and we just focus on the relationship between these two. And what we're going to do is open the investment valve. We're going to give it a sort of push that one over there. Yeah, that's all good. So that it can plot graphs as it goes. We'll do that as we go. What we're going to do is we're going to open this one. It's settled down to an equilibrium first, and I think we're pretty much at an equilibrium now. And the equilibrium we're going to go for is 1, 2, 1. 1 through government, 2 through the high street, 1 through the bank. And we're going to have interest rates are fixed. Is that open, the valve? Yeah. So interest rates are fixed. So there's a constant head device at the side such that this water level always stays the same. And because interest rates depend on this water level is not going to move. If this goes down, we just put more money in, or if it goes up, we take money out. through this pipe here, which is the sort of treasury pipe. We can sort of destroy money. Do they do that? I know they print money, but do they ever... Sorry?
Buy back government bonds.
So they buy back government bonds. There we are. I don't know how to do it. I know how to do it on this machine, but I don't know how to do it in reality. So we're going to do it with a fixed interest rate. So this, how we're going to measure it, this pen plotter here, because it's got a load of pulleys around here that basically are powered off this big float on this tank at the bottom. So this floats on this tank, and so it measures this height. And if you know this height, you know Q is the income. So we can measure the national income by that big float, and we can power it there. So it's going along at the moment. This national income is 4. It's 1, 2, 1. It says 5 there, but that's because the fishing wire shrunk. if I make the fishing wire a little bit longer, it'd be 4. Okay, but it's at 5. We're going to do everything with marginals, so let's just ignore that and let's call that 4 there. 1, 2, 1. And what I'm going to do is open this one by 1. So we're going to have 4, we're going to add 1. And by the magic of economics, 4 plus 1 makes 6. In engineering, 4 plus 1 makes 5. But in economics, 4 plus 1 makes 6. There's the magic of the Keynesian multiplier, which someone can explain to me. Emily, why does 4 plus 1 make 6 in your department?
You didn't tell me you were going to make me explain this. I'm actually an economist and not a historian, but because it goes round and round again, and the marginal propensity to consuming is it's like it all adds up to 1.
The butcher pays, the baker pays, the candlestick maker. It goes round, so you add 1. So think about it. 1 comes down here, and we've got a graph here now, which is the propensity to consume. And this is set with a slope of about 1:2, which means that in this model, you spend half, you save half. So half is spent and half goes to savings with this way of doing it. So you've added 1, the 1 goes round and comes down here, and now half goes this way and half goes that way. And that half essentially disappears because we're just sort of keeping the interest rates pegged. So we can forget about that half, but this half is now coming down here. This half goes round, now splits quarter. And this quarter goes round, you've got an 1/8 and an 1/8. And so we've now got a half plus a quarter plus an 1/8, which is the extra 1, which has now appeared out of the magic of economics. So the way this works is that this will open, and so this should go from 2 to 3, and we'll end up with 1, 3, and 2. This one has shifted from 1 to 2, and then we get the extra 1 by this opening up via and the amount that it opens up is given by the slope of this graph, which is, and the multiplier is the 1 over the marginal propensity to save, which is 1 over 1 minus the slope of that graph.
Exact. This has not worked. Every time that we've done it in the last couple of weeks.
A few years ago, it was working beautifully, and I've got everything nicely oiled, and it was all working. I could be within a couple of % of the actual economic equations. Whether this is a model of the economy is a long debate you can have, but in terms of the equations it's trying to solve, this is a very good physical model of those equations, and I can get it within a few %, but at the moment it's not working very well. So, so we're going to try it. Emily can open that in one sec. Let me just put the pen plotters on. Yes, that's... Yeah. And the pen plotter's turned on. Yeah, it's moving. Yeah, it's good. So this will plot graphs. This one is income, and that one is interest rate. So that one should stay flat. So the interest rates are currently standing at 3.5%, and that should stay completely flat. And then we'll just draw a nice little straight line to start with to show that we are at equilibrium, and then we will open that by 1. And the prediction is as we open this from 1 to 2, this one should start to open from 2 to 3. But it hasn't been doing that this week, and I don't know why.
Do any of you have any ideas?
It used to do it in the past, but post-COVID, it's a bit... It could be rusty. There's gunk in it. There was all sorts of stuff in it, but we'll have a go. We should see it open a bit, but it probably won't do the full 1. So anyway, here we go. We've got a beautiful line go along at 5, which is really 4, and now you add your 1, and we'll see what happens with the 1. Okay, so what we now should see is that this should start to rise, because we've increased this, so we've now got 1, 2, 2. because we've made that a 2. So this one is, the pen here is now starting to rise. So national income is going up, but that's because we've increased investment. And now what we want to see is more than the 1. We want to see 4 plus 1 making 6. And so we need to watch this one here. And it has opened up a bit, 2.1. It's now 2.1, it was 2. And if we're lucky, it's going up towards 2.2. So it is heading towards the 3. So it's doing what it wants to do. But at the moment, there's something sticking, I think, and it won't get all the way up to 3. But we should see the graph over there rising rather nicely. So where else could I talk about while doing this? Bill Phillips, at this point, where did we leave him? He'd gone to London, and then the war broke out, and he headed back to Singapore. He joined the Air Force, the Australian Air Force, I think, and he was decorated for his bravery in action. He was then shot down over the Coral Sea or the Timor Sea somewhere, ended up in the forests of Indonesia, and he was he found a bus, and if you've ever watched Scrappy Challenge, you know that a bus, you can just turn it upside down and you've got a boat, and then he was going to sail this back across the Timor Sea to Darwin, but he was sort of betrayed and he ended up in a prisoner of war camp there. And he's actually mentioned in the books of Lawrence van der Post, who was also in this prisoner of war camp. They mentioned this New Zealand officer who was amazing, who did all sorts of exploits, like he made radios because he was an electrical engineer out of bits and pieces he found around the the prison camp, or he stole from the guards' office at night. Very, very, very dangerous. And they'd hide the radio in the chair leg, and if they found the radio, you'd be beheaded, basically. I mean, it was extraordinarily dangerous. Very, very brave. He also had a system for making cups of tea for the prisoners. I've heard this told 2 ways. One was that all the lights went down in the prison camp at 8 o'clock at night because Bill Phillips was making 2,000 cups of tea. But another version of the story says there were lots of little immersion heaters that were sort of pocket-sized, but that you could make your tea with. But anyway, either way, Bill Phillips had a way for making cups of tea. When the war finished, so it's gone up, and it's just gone up. It's a beautiful exponential curve, not exponential that way, but a sort of 1 minus e to the minus t. You know, it's a linear equation, it's a linear system, so a linear first order ordinary differential equation, so you get a 1 minus e to the minus t with a time constant. But we haven't really got the multiplier going in.
It should have opened up all the way to
It's gone up to 2.2, it should have gone up to 3, so I apologise for that, but we decided to go ahead with the talk anyway, even though it wasn't quite performing properly. It's gone up to 2.2 rather than, so we did get an extra, we added 1, yeah, 4 plus 1 makes 5.2 today rather than 5. So we got a bit of a Keynesian multiplier, but you'll see interest rates stayed constant on the other graph there. After the war, he went to the London School of Economics. He was studying sociology there. By this time, he was a very, very heavy chain smoker, and the story is told better by Nicholas. He has a chapter in a book I'll show you in a minute that explains it. That Bill was studying sociology, part of which he had to study economics, and he got quite into the economics. And he went to see his tutor, and he said, well, these economic equations are quite hard, but I think I can make a model of these. By this point, he was getting a pass degree in sociology, because he was whether it was because he was smoking too much and couldn't sit through an exam, I don't know, or whether it was just he got so into the economics. He wanted to study man's inhumanity to man. Anyway, he said to his tutor, I think I can make a model of economics out of plumbing gear. And the tutor, to his eternal credit, said, go on then. Because you imagine you've got a pass degree, so that's lower than a third, coming to you with an idea like that. I'd have, you know, probably wouldn't have been very so generous. So that the person involved was actually James Mead, in whose room we're sitting. So there was a lot of people involved, Robin and so forth, but James Mead was the one who sort of showed the faith in Phillips to say go on. And so Phillips and Walter Newlin, who's the other story, they went and built this one. Do you want to take it back? Yeah. So we got a beautiful exponential curve, but the multiplier didn't work at all very well. And I'm sorry about that. Emily will take it back to the equilibrium. We can lift this pen off the paper now. and push it back. You can take that one off altogether, and push it back to the start. And we'll repeat that experiment with a fixed quantity of money and variable interest rates. And so we'll see a phenomenon called crowding out, I believe. Where was I? Mead said, OK, go on and build one. So he, and with the help of Walter Newley, went to a garage in Croydon and they built the first model for £100. So Willie Brown's father gave the money. So I don't even know Willie Brown, but he was the head of this department, absolutely wonderful, lovely man who only died a couple of years ago, very sad. And Willie Brown's father gave the £100 to build the first one. And the first one now exists up in Leeds, and it's just the top half, and it's a sort of historical artifact. It doesn't work. This is a Mark II. The Mark I is in Leeds, and this is a Mark II. And there are about 14 Mark IIs were made. The Mark I doesn't work, and it shouldn't work because it's a historical object. There's only one of it. So you shouldn't let people like me start to play with it, because there's a dynamic tension between conservation and restoration. And if you've got an object of value, you don't let me play with it. But there are 14 of these, so the department, there's one in the Science Museum from the LSE which is perfectly preserved, so the faculty here decided it was good to have a living one. There's a dead one, perfectly preserved, why don't we have a living one? And so they allowed me to restore this. So I had a very happy time in the year 2000. Took this on its back, out of the window. It was quite hairy, and we took it over to my department, fixed it, and then we brought it back up through the window and put it back here. And we did get it working very nicely. So we should be back at our initial equilibrium now. Pretty much, yeah, we're pretty much on fire. We're back at the initial equilibrium. I'm going to repeat that experiment, but with this time we're going to let interest rates vary. So I'm going to turn off the ability to burn or sell bonds or print money. So I'm going to turn that off. So I've now got a fixed quantity of money, which is monetarism. Is that right? Fixed quantity of money? Is that monetarism, loosely speaking? So we're now going to run a monetarist thing. And what I'm going to do is I'm going to repeat the experiment. And you've all got to think this through, because I normally do it the other way around, so I'm going to get this wrong. We're going to open that. So we're going to open that first. And so because we've opened this, increased investment, more water is going to flow out of the bank, and so this level is going to drop, which means interest rates are going to go up. And if interest rates have gone up, people are not going to want to borrow it because interest rates have gone up. So this graph here, which is powered by a float on the bank over here, it's going to say, hang on, interest rates have gone up, I don't want to invest so much, so it's going to try and shut it again. So as we open it, interest rates will change in a way. We should see that over there. That will go down, interest rates will go up. And then this will change this behaviour and we'll start to shut it again. Yeah? So it will crowd in to this phenomenon. So rather than getting a nice all the way up, we should just get a sort of lesser curve because of this effect on interest rates. So shall we try that? Just push it back a little tiny bit. So we've got to put this one on, because this little graph is the one that is powered off the float on the interest rates. Whoa. Did that one. Hang on, it stops. Ah, you're crushing my finger. It's got to go on.
Sorry, there we go.
Okay, so we've now got this steep as we can. We've put that graph in, which is people's behaviour for investment with respect to interest rates. So as interest rates change, people's behaviour changes. So let's add one.
Have you done that?
Have you done it? Did we do it? Did we shut it?
Yeah, I think so.
Add one. So we've added one. So we're going along flat at 4, and that is shut. So we can start to see interest rates rising now. So interest rates are rising, and this should have an effect on people's investment behaviour. So this is starting to rise, but this has already come in now. We opened that to 2, but it's now already shut down to 1.8 because people don't want to, 1.7, people don't want to invest quite so much because interest rates have gone up. So that's crowding in, crowding out, I believe. It's a rather subtle version of crowding in, crowded out, to my mind. The one I'm more familiar with is government expenditure crowding out private investment. Is that what you teach at A-level? I don't know. The one I think of is that if the government spends the money, the private people don't want to, so you've crowded them out of the market. And so when I'm explaining it to high school kids, it's sort of, for me, it's like the Tories versus Labour. This is a sort of, that certainly when we were talking to the austerity years, it was very clear that Cameron and Osborne and people thought you should decrease the government expenditure, and this would therefore automatically open up the private investment. And is it true or not? And the only example I could think of that really showed it was true was student tuition fees, student loans. Because previously, students' education was paid for by the government, but if the government says we're not going to do that, they shut this down, and then the students have to borrow the money to invest themselves. So student loans go that way. So how does it work? The student loan company takes it over there to the government and sends it back that way. And instead of it coming down this way, the government says, no, you've got to go around that way. So it has no effect on the economy whatsoever. It's exactly the same amount of money, except the government has hidden, the public sector borrowing requirement is now hidden in your personal bank accounts, in your personal debts. It's hidden. And apparently the bond markets that's tricked them, and they don't realise that we still have the same national debt, except it's in your private accounts. And I tell this to some students and they get really cross. The only students who don't get cross are economics students. They don't seem to mind. They seem to think it's a good idea. Yeah, I don't quite know why.
They're going to make loads of money.
Yeah, they're going to make lots of money. Engineering students get really cross about this. Anyway, so that's the crowding out. It's gone down to 1.5 there, so that did work, the crowding out. Shall we go back to square one again? So we can see there's a lesser growth there. I think that should be visible. You can come and look at this later and have a look, but there's a lower curve there. So let me pull the pen plotter off. Interest rates did go up. First thing to do is open the interest rates again. And what we're going to do is we're going to repeat the first experiment, but with the accelerator in the equation. And the accelerator is this bucket down at the bottom in the tank of water here. There's a bucket there with a hole in, and as the water level varies in this tank here, and there's this bucket in there, imagine there's a huge hole in the bucket. The bucket will just stay there, and the water level will go up and down while the bucket stays there. Imagine there's no hole in it, the bucket will just go up and down with the water. Yeah, so there's these two extremes. But if there's a small hole, the bucket kind of tries to follow it, but it's sort of lagging behind. So this is the bucket, and the bucket sort of lags behind what the water level is doing. And so you can tell from this differential, the difference between the water in the bucket and the water in the tank. If the bucket's above it, it means it's going down, and if the bucket's below it, it means it's going up. So you've now can measure the rate of change. You've now can work out that's a higher derivative. So we go from a first order differential equation to a second order differential equation, and we can use this difference. So basically, if it's going up, and this is the water in M1 is going up, and the bucket's going up, it's going up. So people now want to invest because there's good times ahead and everything's going up. So now investment is going to increase. And so the bucket has got a fishing wire that goes up to here, which is attached to this bell crank, which we can attach to the investment, which will then open the investment and increase it. So that's how that all works there. So when we get back to our 111, we'll repeat the experiment. And what should happen is that it should go, as we add the 1, the economy should rise, people will detect it, and the bell crank will then open to get even more investment. And if the multiplier was really working well, we would get a really sort of virtuous circle that therefore there's going to be more investment, which is going to feed more investment, which is going to feed more investment. We should get really fabulous growth like so. So we're hoping that it just gets sort of more than the first graph is what we're going to do. So let's take this back to there, and we'll repeat it with the accelerator. So this is actually, I call it optimism, but it's really more a model of capital deficit. If the if the market is going up, and this is sort of how much you can produce, you need to invest in more machines to keep up with the supply. So you have to invest in more machines to keep up with the growth. It does work the other way, and maybe I should do it, let's be positive and optimistic, and let's have some growth rather than doing it where it just heads down and down and down, like, like 2008. Okay, so this is the accelerator, and we'll see if it works. I don't know if it will, but we can try it. So the hole is completely open at the moment, so you're going to shut the hole totally. And now I'm just going to open it 1.5 turns. So there's half, 1.5 turns. It's possibly all a bit bunged up, so it may not work, but we will in a sec. Before we add it, we can add it there, and we've taken that one out, yes? That's good, and we've popped that. Okay, so I think that's all done. We're back at an equilibrium there of 4, so we'll just add the 1 again, but this time we'll do it with the bell crank attached. So we go to the 1, let's push it over there and open it to 2. So I've opened it to 2. And if this works, the bell crank should open that to more than 2, which should then give us the feedback through the Keynesian multiplier, and so we should get even more than 2, and more than 2. We get a virtuous sort of cycle. Where have we left Phillips at this point? He was at the LSE. He essentially went from a past degree in sociology to the most prestigious chair in economics at the LSE within 8 years, I believe, was this astonishing sort of trajectory. And one question I have is, why would a qualified engineer have 240 volts straight into water? And I've wondered about this for many years, and I've put it to audiences, and someone suggested to me that actually their suggestion was, how do you think he made the 2,000 cups of tea? In the prisoner of war camp, he possibly did put bare wires into the water, which is a very, very dangerous thing to do, but nowhere near as dangerous as making a radio and hiding it in a chair leg. And on the scale of danger, this was comparatively less dangerous. I said this on a video I made of this once, and I said it's not dangerous to put 240 volts into water. Yes, it is, kids. Please don't put 240 volts into water, it can kill you. So please don't do that. So anyway, we've stepped it down to 20 volts now. It should be rising. It is rising, but we haven't had any movement on the bell crank, so the accelerator hasn't worked. I apologise. However, we do have graphs from the day that I did unveil this in 2001, I think it was, when I first restored it. So the first graph over on this sheet here is the first experiment, which goes up and does show you the Keynesian multiplier of 2. This is it when we came down from there, and we get the crowding in, crowding out, and it's nowhere near as dramatic. And then this one over here is with the multiplier, which really does whoosh up a lot higher. I then hit an end stop, and it stopped there, but the multiplier was far more dramatic. I did this on the day, they were celebrating 100 years of the Tripos here at Cambridge, and I thought that was all a bit parochial and Cambridge and inward looking, but then I realised just how astonishing the 100 years at Cambridge have been, and all the incredible people who have been here for 100 years, in the last 100 years. And this was the branching point from economics as a subject from moral philosophy, the Cambridge Tripos, when they sort of called it economics, and it diverged from just moral philosophy. So it was an incredible honour for me to speak on that occasion. The great and the good, all the amazing alumni that have come out of Cambridge, and in particular interest was that at one point I was up here explaining interest rates to Sir Edward George, who was the governor of the Bank of England at the time, and I was sort of explaining how interest rates work. This is apparently a really good model of interest rates. Apparently Keynes and Robertson argued a lot about what set interest rates, and I believe that Phillips's take on it is both Keynesian and Robertsonian. If you look at it Keynesian, this is Keynesian. If you look at it in another direction, it's Robertsonian. And Keynes and Robertson didn't live to see this, but there was a sort of bit of a synthesis of the two. But Nicholas probably knows much more about that than I do. I'm really out of my depth with that. So it didn't go up any higher. The accelerator didn't work, I'm afraid. Maybe the little hole is clogged with COVID-related stuff still. I don't know. But it did used to work. And in fact, what would happen rather nicely was when I was giving this talk, I'd just sort of keep talking. And in the background, the machine would keep going. And I was giving a talk one day, and I noticed with the multiplier that it had sort of gone all the way up to the accelerator and the multiplier. It had gone all the way up to the top. It had carried along, and then it started to plummet again. And it had automatically, without me doing anything, gone off onto good business cycles. So there was a fellow at Peterhouse 20, 30, 50 years ago, Richard Goodwin. He was very big on the business cycles theory, and I think this sort of settled down onto a Goodwinian business cycle with sort of boom and bust. Once it hit the top, there was sort of no longer any incentive to invest anymore, and so people stopped investing, and then it went down, and then you got the virtuous circle reversed, and it went down to the bottom and then carries on. And we're getting business cycles of about 11 years, which sort of does sort of correspond to my recollection of what happened over my lifetime, roughly speaking. But I think there's a problem that this was realistic, this is realistic, this was fairly realistic, this was realistic, but this wasn't. I think the machine does that, but the real economy would have just kept going there until someone actually decided to invest again. And whether it's Keynes, you know, burying pound notes or whatever to do this. Sometimes the machine runs dry when I'm talking to kids about this. The machine has run dry and it just starts to make funny noises, and I realise, oh no, we'll have to print money. And the kids are like, no, you mustn't just print money arbitrarily, because they've all studied, you know, the Weimar Republic and Zimbabwe and things like that. And I say, it's fine, we'll just do some quantitative easing and just pump some money in, and it all comes back to life again, which is largely what they were doing in 2008 with the I'm at the edge of my economic knowledge here. So the other experiments we could do is to repeat this experiment on the foreign sector over here. So this experiment with the Keynesian multiplier, I can repeat on the foreign sector, which is almost the same sort of hydraulics there with the sterling balances abroad. And to my simple mind, this explains why we're not fabulously rich from North Sea oil. Because what I think happens is when North Sea oil was first discovered and we started to produce it, we could reduce imports and we could increase exports, and so we should have been going up and up and up. However, the change in the exchange rate, which is like the change in the interest rates, crowded in or out, whichever it is, and eroded into that, and so rather than it going up, it just sort of didn't go up anywhere near as much as it could. And I've explained this to groups of very established economists, and they said, no, Alan, that's all wrong. But then this is when someone else says, no, well, you're wrong. And then actually the economists all started arguing with each other. So I might be wrong, but then half of the audience is wrong, at least. I know that. So that's anyway my theory of why we're not rich from North Sea oil. There's a few other things I should say. We can possibly turn it off now, Emily, because it's not going to do it. I've got papers which show the Goodwin cycles and the mathematics of it. One of the beauties of this machine is its solution of differential equations. I'm also a mathematician, and this integrates. It's a differential equation, you integrate it. And have you ever seen anything sort of more crisp than the concept that you integrate it by pouring water in a bucket? You've got a flow, and you just pour it into a bucket and you integrate the flow. And that's how he solves his differential equations, by pouring water into a bucket. And I work on other differential equations, you know, in my life. I got Bayesian this and all sorts of other things with stress analysis. And I do wonder, you know, if I was really smart like Bill Phillips, I'm sure there's a bucket and a pipe that would sort of solve my equations. But I've not done that yet. Although I've got a view for the Bayesian one, actually, with posteriors and priors and predictive distributions. And you have one. The beauty is you have 1 litre of water, because that's the one of probability theory, and that's kind of got to go somewhere. But that's another project. This is also an artwork. When we turn it off and it trickles down, you know, it's trickle down economics. Many a cameraman has sort of stood here with his microphone and broadcast that on the radio. People like the sound of it. People like the look of it. This went to the Venice Biennale in about the year 2000. An artist juxtaposed, not this one, but a New Zealand Phillips Machine with a New Zealand Land Rover and some New Zealand boxes of butter, and that was the New Zealand exhibition for that year. There's someone got some money from the Tate Modern. There were 14 of these made. So one went to the Ford Motor Company, one went to the University of Manchester, Cambridge, Harvard, Yale, there's a few, and the Bank of Guatemala, which is the kind of funny odd one out. But there was is it Abe Lerner? Is he an economist? I think he was. Well, yes, someone got some money from the Tate Modern to go on a quest for the Guatemalan Phillips Machine, and it's all documented on the Phillips Machine on the Tate Modern website. How he went to Guatemala and he looked around. He didn't. Spoiler alert: he didn't find it, but he met someone who had seen it. So there was one in. But if you're ever in Guatemala, I mean, just ask around, and you never know. You might find a Phillips Machine in the jungle there somewhere. What else have we got to say about this?
Can you do that other diagram?
Oh, I will do that in a second, yeah. Or maybe I'll do it now. Yeah, let's just rotate that round. One of the reasons I got into this, actually, before I show you this on the back, I think I have to move the whole thing that way a little bit. That's it there. Is that I teach engineering. I actually teach, amongst many things, I teach water engineering. I give lectures on water engineering. And I tell my students, if you're going to be a water engineer in the world, you need to know much more than about pipes and pumps. You really need to know about sociology, economics, environmental science, sociology, all these other aspects. You can't just know about pipes and pumps. You can't go to, say, India and just put pipes into a village and hope it's all going to work. You need to understand gender issues. There's a whole host of things. And this is sort of one of the really interesting to me was when someone told me, I'm telling my students you should study economics, and then it turns out the economist should have studied water engineering and hydraulics to do this. So it's a wonderful sort of volte face, but it's not just the hydraulics of this machine. I fundamentally believe that the way to greatest economic development in all the developing countries is via water engineering. That if you put the pipes into the villages and take the sewage out via the pipes and the pumps, people get healthy, little girls can go to school instead of fetching the water, and economic development takes off. You don't need to, it's not about even the schools or even the microfinance. It is actually just getting people healthy via water engineering. And I sent my students, a PhD student, to go and measure this economically in India. She and her father have changed the lives of about 6 million people by putting the pipes and the pumps into the villages, and they measured multipliers of 85. If you put in $1 into the investment in the water infrastructure, the benefits were just absolutely, that was a bit of an outlier, 85, but 20, 30, 10, 5 was the multiplier you could get. And the beauty of it wasn't foreign aid money, it was the people's own money. So I was accused of being part of the Washington Consensus or something, and I wasn't. It was the village's own money, just organised to put into water engineering. So me giving this talk, I can say that in front of economists who can go away instead of, when they're trying to win their Nobel Prizes in development economics, they can think about water engineering and its centrality in world development. This is actually, there's probably no engineers here, but this is for engineers, just to explain something really amazing with the engineering. This whole thing depends on this propensity to consume curve. The experiments we did, it didn't work, but maybe today we can spot what went wrong today. This propensity to consume curve is this one here that separates the income after taxation into savings and consumption that way. And so we've got the graph here, Y minus T versus C this way, propensity to consume of your net income here. So how's he going to do this? Because it's a flow. Y minus T is a flow, it's not a stock. You can't put a big float on a flow. You can put a big float on the stock. So how's he going to do it? So the first thing he does is he puts the tank up at the top. The first tank has no economic meaning whatsoever, but at the side of that tank there's a sutro weir, just like the one at the bottom. So now he knows that that head height there is proportional to that flow. So that head height is proportional to Y minus T. So he now runs a little manometer out of there. Here is this 240 volt water detector that checks the manometer level of this. The wires from that go around over here to a little motor, which we think might be a windscreen wiper motor off a Lancaster bomber, but we're not sure about that. And that then, depending whether it's touching or not, toggles this little armature back into here. There's an auxiliary pump, again of no economic meaning whatsoever, that pumps this sort of circulation round at the back. And so this water coming in, either goes this way and turns the water wheel this way, or it goes that way and turns the water wheel the other way. That water wheel drives this shaft, which turns a worm gear, which turns a cog, which turns a pulley, which goes back to this pulley, which then turns that pulley, which then lifts this up. So this is going up and down because this water level is going up and down, and they go up and down together like that. It's an absolutely astonishing piece of engineering. And not only that, but there's two of these at the back, because there's one also on the foreign sector, so I've only just drawn the top one, but there's another one lower down at the back. When we first got this machine, it was all sort of in pieces, and we couldn't work out. It took us a month to work out what on earth this stuff was round at the back. You can have a look round at the back. It took us ages to work out that this was just merely to get the propensity to consume there, like so. Finally, I think we're at finally, is that Cambridge University Press very kindly donated some books. There's this fabulous book, Robert Leeson books. It's got all of the Phillips complete works in here. He only wrote 18 papers. We're meant to write that every year at the moment. He only wrote in his whole career 18 papers, and they're in here together with lots of commentaries from lots of famous economists about Phillips and his life. There's a wonderful chapter in there by Nicholas, which is really worth reading, that tells the story of Phillips' life much better than I can tell it. And we have about 20 of these to give away for free. So there's more than 20 of you here. So who would like one of these? If you would, put your hand up if you would like one of these. We have a box around the back. 1, 2, 3, 4, 5. They're not free, they're £65, okay? And that's an example of a demand curve, which is on the back there. They are actually... They're £10. They're £10, which is sort of fairly near the thing on the back. And they're available from the library upstairs for £10. So, but they're courtesy of Cambridge University Press. So was that clear anyway, how that worked? I hope that was clear, that's what then separated your consumption to your savings behaviour. Have I forgotten to say anything?
No, that's everything.
Okay. Happy to take questions or? Okay, thank you. Well, thank you. No, thank you. Feel free to take photos.